Okay, it's time to talk about what a p-series is. Very simple, okay? They're really not complicated because they all look like this. It's a series from 1 to infinity of 1 over n to some power, and it converges if that power right there is bigger than 1 and diverges if it's 1 or less. All right, and that's it. So we'll look at this example here. Like say you have the series 1 to infinity 1 over n. That's a p-series because it's like 1 over n to the first power, okay? So it's a p-series. The power p in with regards to this formula is 1. Series looks like 1 plus a half plus a third plus a fourth plus forever. This series diverges because it says a p-series will diverge if the power is 1 or less, okay? All right, so that's a p-series. P is 1, it diverges. What about this one, 1 over root n? Well, the square root of n can be converted to a power. You could say that root n is n to the 1/2 power, right? So it is 1 over n to a power. The power is a half. It looks like this, 1 over root 1 plus 1 over root 2 plus 1 over root 3 and so on. That series also diverges. It's a p-series. P is equal to a half, and a half is less than 1, all right? Okay, let's look at one that converges. 1 over n squared. That's a p-series where p is 2. It's 1 plus 1/4 plus 1/9. You get the idea. It goes on forever. That series converges. We said a p-series would converge if the power p is more than 1. Now, all right, so it converges. What does it converge to? If it converges, it's got to converge to something. I mean, you add these numbers up, and the more of those numbers you add, the closer you get to something. That's what it means when a series converges. I mean, you're going to add forever. And the more you add, the closer you get to something. What does it converge to? Well, there's no easy formula to calculate the sum of a p-series. There just isn't, okay? For this particular p-series, in the 1800s, a genius mathematician proved that this series converged to pi squared over 6, all right? So it's not easy to do. We're not going to worry about calculating the sum of a p-series. We'll figure out if they converge, but as far as what they converge to, we generally won't worry about that. Okay, but this one, just since we're talking about it, that one converges to pi squared over 6, okay? Pi squared over 6 is about 1.64, so I did a little experiment. I calculated the sum of the first 50 terms of this, and I used Excel on my computer to do it. I was just curious to show you what it would be, all right? So the sum of the first 50 terms would be 1 plus a fourth plus a ninth plus a 16th, and you'd keep going, and eventually that very last one for this partial sum would be 1 over 50 squared. And I calculated that that's 1.625. That's not too far from this. I mean, when we say that series converges to pi squared over 6, we're just saying the more terms you add, the closer you're going to get to that, all right? So already with the sum of the first 50 terms, I'm almost there already. I mean, we'll never actually get pi squared over 6, but the more terms we add, the closer we'll get to that, okay? So that's p-series. There's a lot more to say about it, but for Calculus 2, that's about as far as we take it. I want you to recognize them when you see them, be able to tell if they converge or not. And it might be interesting to know that with some advanced math, you can figure out what they converge to, but generally it's not something we're going to worry about in Calculus 2.